Hi everyone. In this lesson we want to see how we can add and subtract radical expressions. Now if I have 9 square roots of 50 minus 4 square roots of 2, that's kind of like having 9 apples and you're taking away from it 4 oranges. They're different quantities and so you can't subtract those. But notice that 50 does have a perfect square factor within it that I could simplify. I could write 50 as 25 times 2. And then I can bring out the square root of 25 as 5. So the square root of 50 is the same as 5 square roots of 2. And if I have 9 times 5 square roots of 2, that's 45 square roots of 2. Now if I have 45 square roots of 2 minus 4 square roots of 2, well, that's kind of like having 45 apples, take away 4 apples. So that's going to give me 41 apples, or in this case 41 square roots of 2. Remember, technically what you're doing when you're subtracting like terms is you're really, in this case, you're factoring out the square root of 2. This is really 45 minus 4 square roots of 2, when the 45 minus 4 simplifies to give you 41. Now I can do the same thing over here in this next example. If I have 4 times the square root of 3x cubed minus the square root of 12x, I can't combine those at all right now because they're not like terms. But if I simplify the radical, I could think of 3x cubed as being x squared times 3x, because x squared is a perfect square and a factor of x cubed. Same thing over here. Let's think of 12 as 4 times the 3x that's left over. Then I can take the square root of x squared, which is going to be x, times the square root of 3x, and then the square root of 4 over here is 2. And I'm again left with the square root of 3x. So now I've got 4x square roots of 3x, and I'm going to take away 2 of those square roots of 3x. So that's going to give me 4x minus 2 square roots of 3x. Another way, again, to think of that is I've really just factored out the square root of 3x on the right-hand side here. And that would, notice if I distribute, I'd get 4x square roots of 3x, that's this term, minus 2 square roots of 3x, that's the second term. Okay? All right, let's do one more like that in terms of a cube root. If I had the cube root of 54x minus the cube root of 2x to the fourth, again, they're not like terms. I can't combine them right now, but maybe if I simplify them, I will be able to. So this is the cube root of, well, 54 has 27 as a perfect square factor. And 27 times 2 gives me 54, and x is not a perfect cube, so I'll just leave it over here on the right-hand side under the radical. And here I've got the cube root. Now x to the fourth is a perfect cube. It has a perfect cube in it. It's x cubed. And I'll be left with an x. That'll make x to the fourth. And the 2 is also a leftover. I can't take the cube root of that. So let's go ahead and simplify this. The cube root of 27 is 3. So I'll have 3 cube roots of 2x minus x. The cube root of x cubed is x. And I'll be left with the cube root of 2x. So if I have 3 cube roots of 2x and I take away x cube roots of 2x, that's going to leave me 3 minus x of those cube roots of 2x. Okay, or again, just think of factoring the cube root of 2x out on the right, and you'll be left with 3 minus x here.